Is Bharat Ramani, and I'm going to give a brief introduction to the webinar. The disruptions and new business models being developed in the automotive space are at a pace we have never seen before. We have two great speakers who are going to share with you what's happening in the ecosystem. I'm sure all of you are keen to know what challenges and opportunities are there in this space. In future, with these new technologies, will we still own a car or share the car? What about insurance? What about new safety features which may save us from accidents and death? Let me introduce you to Mr. Sanjay Puri. Sanjay is a thought leader on US-India relations, an active entrepreneur and mentor. Sanjay has spent much of his career as an entrepreneur across multiple business sectors. He has built and exited companies in technology and healthcare. Sanjay is focusing on connected transport, a critical component of smart city technology initiatives taking shape around the globe. He founded AutoNebula as an accelerator for entrepreneurs who develop technologies for connected transport in the US and India. Sanjay is also chairman of Velison and SL360. Over to you, Sanjay.
Thank you, Bharat. Thank you for that warm and very kind introduction. It's a real pleasure to be here to talk about a subject that's not only front and center in the news, but also dear to a lot of people who care about global economy, who care about the environment, who care about quality of life, and most importantly, care about safety. Just to give you a quick idea why we are talking about the autonomous vehicle ecosystems challenges and opportunities, it is because I got involved in the formation of AutoNebula about 2 years ago. As Bharat mentioned, advanced technology and shorter development cycles are disrupting the global mobility industry. And the startups are the ones that are really leveraging and driving this opportunity. And a lot of us have heard about the huge success stories that have happened with Cruise and Argo and others. But then there are others who are coming in who aim to be the Teslas of the world. AutoNebula was started as India's only sector or vertical specific incubator and accelerator. And our focus was on connected transport. And the reason we did that was you need subject matter experts. You need mentors who are focused on this area because there is a lot of expertise that needs to be shared. So we launched it in early 2016, and it was actually launched by our speaker today. And we have successfully incubated over 24 startups from across various streams in this space. And we, as an incubator accelerator, conduct and participate in meetups, webinars, events, and connect the startups to OEMs, to tech firms, to tier ones, to tier twos, experts, and investors in this ecosystem. And the whole goal is that by doing this, we will mentor potential startups and create an ecosystem that will be very, very successful. We also have an investment fund and an angel network that we have created so that the startups who desperately need funding to get to that next level, to create an MVP or create their product or create a marketplace, will have that available to them. With that, I would like to introduce you to our speaker today. We are really lucky to have him. Scott McCormick is going to talk about the autonomous vehicles ecosystems, challenges, and opportunities for entrepreneurs. Scott is really the dean of this industry. He's the president of the Connected Vehicle Trade Association, which is the premier trade association in the connected transport space. He has worked with General Electric's factory as a future program manager within the Aircraft and Transportation Business Systems Division. Scott also serves on many advisory committees and boards, including the board of University of California, Berkeley's Transportation Sustainability Research Center, and chairs this security subcommittee. But more importantly, Scott always has the time to talk to entrepreneurs, to startups, to OEMs, to tier ones, tier twos, because he passionately cares about this ecosystem. Over to you, Scott.
Hi, everyone. Let me show my screen here. Thank you for joining us. What I'm going to talk about is the autonomous vehicle ecosystem, the challenges, and the opportunities that exist for entrepreneurs. Just so you know, the Connected Vehicle Trade Association is an international nonprofit association formed to advance the interests of industries and organizations involved in vehicle communications. And the membership is open to companies, universities, and standard bodies and public agencies. First, I want to talk about the market size and how we expect it to grow. NHTSA, the National Highway Transportation Systems Administration in the United States, is expected to mandate that vehicle-to-vehicle communication using DSRC be available in all new cars produced beginning in 2019. We see that the global connected car machine-to-machine connections and service markets are forecast to see a 32% compound annual growth rate over the next 3 years. Juniper, an analytical firm, predicts that 92 million cars will integrate smartphones into the head unit, or did integrate 92 million in 2016 alone. And worldwide OEM connected car shipments are expected to approach 40 million units this year. There were only 8 million units shipped in 2012. By 2022, which is only 5 years away, there will be 1.8 billion automotive machine-to-machine connections. This will comprise 700 million connected cars and 1.1 billion aftermarket devices for services such as navigation, usage-based insurance, stolen vehicle recovery, and infotainment. This is a chart that kind of shows where we've come from since 2011 with the number of connected car connections, both embedded in yellow and blue for the aftermarket, and the growth that we see happening. And overall, we're expected to generate $422 billion by 2022. That's over 20 times the number that we had in 2012. And 59% of that revenue is accounted for by services, both connectivity and the application supported it. By 2022, applications that support it and connectivity expect to be 88% of that $422 billion. This is kind of a picture of the value chain, the adjacent domains, and the new technologies that exist. Across the top, we have what the value chain actually operates now. You have hardware, onboard software, some mechanism to communicate, a delivery infrastructure, content and connected services, those being provided to the vehicle OEMs, and then to the end users. On our adjacent domains, we have insurance, utilities, media and entertainment, telecom, healthcare. To give you an example, the insurance is dealing with usage-based insurance and understanding how your driving behavior affects your actual pricing. Utilities is primarily concerned with the electric and hybrid market. Imagine having 100,000 electric or hybrid vehicles coming into downtown as people come into work every day. First thing everybody wants to do is charge their vehicle up. The last thing that the utility company wants is this huge load on the network during peak hours. And then you have media and entertainment. As we get more and more levels of automation, now you have the time and the ability to do other things in your car than you've been doing before. And of course, telecommunications, regardless whether you're talking about cellular, satellite, Wi-Fi, or DSRC, all play into all of these aspects. And very importantly, you have the whole healthcare aspects. As we get more and more automation, we have to have more and more biometric sensors in the car, because the vehicle has to know whether the people in the car, and imagine a fully automated vehicle taking an elderly person to a doctor's appointment, if they have an issue in transit, the vehicle has to know what's going on, has to know who to communicate with, has to be able to reroute itself. And when we look at where we're going with the new technologies, it's not a linear thing. It's not just that we have the ability to send information off the client device to the cloud. It's not just data in terms of volumes of data. It could be value of data. It could be the velocity that the data is coming through. It could be the variety of the data. And then we have the cybersecurity issues. And those issues don't include only malicious threats. Those include problems like software collisions and bugs. And then you have the human-machine interface. It's well developed for your handset or your portable device, but that same paradigm doesn't work in the car because those devices you focus your attention on. The car, you only have a couple seconds to look at it. And then we have all of the advances on the advanced driver assistance. All of these things create new possibilities for new business models, a new ecosystem of partnerships, in-car software, connectivity, content services, and end users. Sanjay has this whole PowerPoint deck to distribute if you desire, so I'm not going to go over everything in detail in the interest of time so that we have time for questions. But basically, you have two ways of looking at it. What is the consumer focused and what is the enterprise focused? And what are the different capabilities that need to evolve across all of those stakeholders? So what are the potential areas of interest? An awful lot of people are looking to harvest and store data, but the value is in the knowledge extraction, not the actual harvesting and storing of the data, which is very low margin work. And once you combine that transportation data with retail or industrial or other databases, you will review new opportunities. When we look at real-time decision making with artificial intelligence, it requires what we call second-order intelligence. That's what humans have. An automated car now can detect a ball rolling out into the street and stop or avoid it. That's first-order intelligence. You and I, all people, have second-order intelligence. Ball rolls out in the street. Our simultaneous thought is that a child or animal might be running out after it. So to go from first order to second order is massive computational difference, and we have to figure out a new way to do that. Another opportunity is where the transportation systems intersect. The world tends to look at just what the cars are doing, but you realize that planes and rail lines and shipping and freight and all those other non-vehicle road users, such as motorcyclists or bicycles or pedestrians, transit and their riders, we all need a modular and transferable approach of how you use all of those modes, means of mobility seamlessly. Right now, we're at fourth generation telecommunication capability, and we're approaching having fifth generation. Fourth generation can transmit 200,000 megabits a second. Fifth generation is much larger in terms of the pipeline and the switching speed, and it could transfer 1 billion gigabytes a second. That's enough to download an entire movie-length DVD in less than a second. It also has very low latency, which is the time that it takes a signal to get from one point to the other. 4G has probably 20 milliseconds. LTE takes about 10 milliseconds. That's too long if you're hoping to get a signal that the car in front of you is braking or that it's on ice for you to react in time, for the car to react in time. Dedicated short-range communication can do it in less than 1 millisecond. We have tested 5G and see that we can do it in less than 1 millisecond also. So you can use that 5G now to advance aftermarket devices and cell phone apps where you can't use DSRC. Security is a macro level issue. There's a lot of work being done in terms of looking at potential serious threats. But worldwide, we've never had a malicious threat on a car in the wild. It's all been done by researchers and academics and institutions trying to sell their solution into the automotive market. The real issue is that now that we're getting 100 million lines of code, and with the advancement of artificial intelligence, we'll have 300 to 400 million lines of code. Now you've got the issue of software collisions and bugs. There's a well-understood ratio of 1 bug for every 4,000 lines of code. If you have 100 million lines of code, that means there's possibly 25,000 bugs. If you have a bug on an app on your phone, you discard it and put in another one that looks just like it. In the car, you can't do that. The other big frontier is customer relationship management. The automakers market to everyone, but they only sell to dealers. So when you're now looking at customizing or characterizing your vehicle to a unique personality of yourself, there is no one that can manage that. The dealer can't do it. He doesn't keep a specific image of your car. And then the big issue is synergy. Smart cities need smart vehicles. They need smart roads. They need smart grid. They need all of those things. And as we move towards that, we have to look holistically at all of these areas in order to gain the efficiencies that we're hoping to find. So given the fundamental changes that are taking place, there's a tremendous number of opportunities in and collateral to this ecosystem. In terms of data harvesting and analytics, it's not just about capturing the data. As I mentioned earlier, it's about pairing that data against other non-automotive databases to generate new knowledge. There's obviously an opportunity in customer relationship management and version control. As our cars become more customizable, we have to have the ability to manage everything from software updates to security updates. Data privacy and security are going to become more and more important. As we begin to tether phones and tablets to the vehicle, we've introduced the opportunity for things that can happen bad on those devices to be migrated into the vehicle. And then there's consumer services. If you don't have to, if you're on an expressway and you're using the 2020 General Motors CT5, which has levels of automation that on an expressway, exit to exit, says you don't have to steer or drive, what can you provide to the person in the car? What new services are capable? And then there's the connected car packages. If you don't have to drive and you look at the cockpit that you sit in, it's not geared to work on a laptop or tablet or even read a book. So that opens up a whole new opportunity that says, how do we do different connected car packages, including in-vehicle cockpit accessories? We also have the supply side technologies. As all of these things start beginning to change, the normal value chain for an automaker becomes disruptive. And so providing a mechanism to work with tier 3s and tier 2s and tier 1s, which are the most important aspects, as opposed to working directly with an automaker, allows you the opportunity to bring in a whole new set of products and services that the vehicle doesn't currently have. You also have application development for mobility options. Once you're in the vehicle and once you're no longer bound through levels of automation by maintaining constant focus on your car, you can now do new things in your car that applications haven't been developed for because they would be distracting. And then last, you have information and services for the non-vehicle road users. Motorcycle companies are trying to figure out how to broadcast a "here I am" signal because their biggest issue is people don't see them. But if you're a pedestrian or a bicyclist, you're also a vulnerable road user. And it's important for your vehicle as it approaches levels of automation to be able to receive information from those people's phones or tablets or other devices to let them know that they're there and aware. Now, all of the rest of the presentation is through some more detail on all of these different activities. But what I wanted to do is I wanted to open up the mic for people to ask questions, or at least the text to ask questions. And I'll turn it back should I turn it back to Bharat?
Scott, that was a very good presentation, and we're starting to get questions, and we would welcome questions from our listeners and the participants who joined in. Scott, I'm going to start off by asking some of the questions that have started coming in. What role, the first question is, what role do you see for OEMs, tier 1, tier 2s, playing in the startup ecosystem? Because you've seen a lot of acquisitions happening, whether it's a GM or a Delphi or a Visteon, etc. What kind of role do you visualize going in?
It's a very interesting environment that we have right now. The kind of startups that the tier 1s and the OEMs are purchasing are three basic kinds of companies. One of them is like Delphi's purchase of Movimento. It's over-the-air communication. How do I get away from using the onboard diagnostic port, the ODB2 port, to do communication with the vehicle, and how do I communicate securely? So secure communications is one area. Another area is artificial intelligence. We have seen in the news a lot of very large dollar value purchases that are going on because they're attempting to acquire the people that can do this. Worldwide, the estimate is that there's about 10,000 people that have the requisite skill sets to work in autonomous vehicles, to develop the intelligence for AI for those vehicles. So it's a very, very important field for them. And third, what we're seeing is the move by not only the OEMs, but the tiers moving into transportation as a service. They're looking to acquire interest in Lyft and Uber and other companies that do ride sharing or car sharing services because they view that as the future of where the world is going. And so if you look at those changes that are just occurring right now, then what we have to project out is, well, okay, if a tier one or an OEM buys a car sharing service, what capability does it not have? Automakers and tier ones are not app developers. They are not people that can do personalization of services because they don't have CRM. So there are opportunities in those spaces as we move forward. When you look at the artificial intelligence, right now there's about 63 firms worldwide doing automotive AI. There's probably a world need for about 15 companies. So we're going to see some consolidation. So the question you have to ask yourself is, if I have this ability to develop something for a car, if we're moving more towards artificial intelligence and the machine-to-machine communication, what is now left open or unsaid that how we have to do it? And what that is the behavioral mechanics of the fact that we, for 30 or more years, are going to have everything from the kinds of cars we drive today to the kinds of cars that are fully automated. And so now we have to ask the question is that how does an intelligent vehicle interact with human drivers? The scenarios we're almost always given us when all cars are automated. But the reality is, for most of our lifetimes, it's going to be people driving cars interacting with levels of automation. And there are different kinds of issues that have to be addressed. Many of them are social and behavioral that haven't even been scratched the surface yet.
Thank you, Scott. That was very, very helpful. Scott, the next question that has come in talks about security. Everybody keeps talking about cybersecurity and how important it is. There have been examples of people who have hacked cars, etc. But how come there has not been any major acquisition of a cybersecurity firm by either an OEM, a tier one, or a tier two? Is there opportunity for cybersecurity companies in this ecosystem?
That's somewhat questionable. And the reason is, as I mentioned, worldwide, we've never had a malicious attack in the wild. Everything has been done by researchers. When we polled the automakers, 70% of them weren't concerned about cybersecurity for two reasons. One, it's not scalable. What you can do to one person's car, you can't do to somebody else's car. The highly publicized Jeep hack, they didn't bother to tell the world that those people had that vehicle for 6 months. They physically removed hardware from the car in order to determine how to hack it. And hacking that one car didn't allow you to hack another Jeep identically. However, as we move to over-the-air communication, there's a huge concern to make that very secure. As we go from having 50 million lines of code in a car to 250 million, now you've got a complexity issue. And the third issue that you have is, as I mentioned, you have software bugs that you have to deal with. Windows operating system, when the last one came out, had 100,000 known bugs when it was released, and within 2 weeks, it found another 200,000 bugs. And the reason is it's impossible to validate every different program. If my program is making the same function call yours is, there might be unintended consequences. So dealing with cybersecurity is probably 5% of the issue. Dealing with collisions is about 25%, and 70% of the issue is dealing with bugs. 25,000 bugs for 100 billion lines of code is a lot, and it could be very deadly. So what we're looking for is, when you look for companies going, are you buy a cybersecurity company? The answer is no. Are they investing in hiring the right kind of IT people and hiring those companies or acquiring those companies that don't list themselves as cybersecurity? Because if you can do the bug fixing and the collision fixing you can do cybersecurity.
Thanks, Scott. That kind of leads to the talent question, which you kind of alluded to. One of the questions has come in is, what kind of skills are needed for people to enter into this ecosystem? If somebody were to want, everybody's heard about all these outrageous salaries, and as you mentioned, the shortage of AI people, 10,000 people, etc. If someone were to try to be in this ecosystem, what would your suggestion be in terms of skills that they should have?
Well, let's look at three different areas. One is communications, one is computational power, and one is in-vehicle systems. Okay, that's kind of the cube that we create out of those three axes. So when you look at it, you can have domain knowledge and understanding vehicle control systems, advanced driver assistance systems, levels of sensor embedment that provides automation. That's an important skill set, but generally you have to learn that by doing on the job with the individual companies. Now you go up the path that says we're at 4G or 4G LTE and we're moving to 5G. Those people that are dealing with the hardware aspect I just talked about don't know hardly anything about the communications. So if you, depending on which of those two you have skill sets in, that's where you want to get domain knowledge, is in one of the others. And then the third one is in the processors themselves. Right now that we're at 6th generation computers, we're moving to 7th generation, but we're still following Moore's law. Every 18 months we're doubling the number of processors, and we expect that to keep going at least till about 2024, 2025. And if it does, right, we will now have the ability to do something more. So you can pick any two of those three axes and become much more valuable than you are now by getting more intelligent in that space. I spent about a year developing 120 hours of coursework called the Connected Vehicle Professional Credentialing Program that the credentialing is provided by SAE International, that walks through, here's the hardware, here's the communication protocols, here's the software, here's the cyber issues, here's the regulations, here's what's going on in the world. That course is being taken by a lot of people. In fact, the Ron Felice, who is the chief architect for IBM's Watson Internet of Things, was one of the first graduates of that program. He was an extremely well-versed individual at a very high level of IBM in how Watson worked and how the Internet of Things worked. But in order to understand the automotive space, he had to gain that additional domain knowledge. So you look at computational capability, communications, and what physically is going into the hardware. And if you put all three of those together, when you go out and say, 2 years from now, we're not going to be using necessarily 4G or all LTE, and we're not going to be using 6th generation processors, but 7th generation, and we're going to be past the ADAS point. So we're going to be at a point where you don't want legacy knowledge, you want knowledge about where the world is going.
Great. Scott, the other question has come in is, large parts of the world outside, the Western world, when you go into Asia or even Latin America, two-wheelers is the dominant mode of transportation. Everybody's fixated on, autonomous vehicles in the four-wheel category. Not much innovation, it seems to be happening in two-wheelers. What are your thoughts in terms of when you look at in India or Vietnam or Indonesia, what are your thoughts on innovation within the connected space within two-wheelers?
Well, that's a very interesting question, because there's multiple levels of two-wheel type of capability. In Germany, they've built an autonomous unmanned motorcycle that is for the police, and they're actually testing it so that it'll drive up next to a car and electronically issue a ticket. BMW has just demonstrated their prototype for an autonomous vehicle that the operator could just ride on. He wouldn't have to steer or pilot, and it's self-balancing. The problem is is that all of those are very expensive, very high-end vehicles, okay? When you start going down the train, it says I'm looking at mopeds or scooters or smaller motorcycles because those are much more efficient to use. There's two tracks that are going on. One is electrification. How can I, in Shanghai 2 years ago, they made it illegal to have a gas-powered scooter or motorcycle. And so everybody transferred over to having electric. And what they didn't do was give anybody the ability to say, here's how we're going to handle the power structure for that, for all of the charging. And that created a problem for them for about a year. So when we look at how do we make the road safer, and in fact, Harley Davidson is working with one of the tier ones to figure out how they can broadcast a "Here I Am" signal to cars and to phones so that people can see them on the road. The biggest issue for the motorcycle and scooter people isn't that they need to know that the road is icy, because you typically drive on those kinds of conditions. They don't necessarily need to know what the traffic level is. What they really need to know is how to maintain their safeness, okay? And their safeness is dependent upon making others aware where they are and what their trajectory is. And so that's a very new area that people are just starting to work in, and I think it's an area ripe for development.
Thank you. The next question is, hi Scott, would like to know your thoughts about interest of OEMs in peer-to-peer car sharing companies. For example, acquisition of Flink by Daimler recently. I find the interest in companies like Uber and Lyft, which are more ride-hailing companies. However, would like to know what is the interest of an OEM in acquiring a peer-to-peer ride-sharing company. A peer-to-peer ride-sharing platform is used by general consumers who may not use OEM cars. So would like to understand how you see this playing out. That's a question that's come in for you.
Well, here's the issue. Well, I had about a year ago, I was having lunch with Bill Ford of Ford Motor Company, and he was talking about how his board was telling him that, hey, you need to sell 2 cars in every garage. And he says, well, the world's not going that way. The world's going to car sharing. The problem with peer-to-peer sharing is that the automakers don't have any ownership in it. So the automakers are saying, how do I own an Uber or a Lyft? How do I make the GM's cars, the Bolts that they have out in California that they're using for automated taxis, they own and they self-insure. And to them, that's where the least amount of liability is. Going peer-to-peer opens them up to having to have many, many relationships. And an automaker is not typically used to doing that. They're used to having half a dozen tier ones provide everything into the car. They're not structured to have multiple relationships with peer-to-peer places in different regions, in different languages. They don't have any capability, and they don't know how to participate in the revenue stream. So my expectation is that they're going to continue on the path of becoming transportation as a service by making the cars for themselves to use rather than in a peer-to-peer relationship.
Thanks, Scott. The next question is, what are the most critical new standards being developed, and what barriers are there to their adoption?
Well, you have standards for charging, both fast charging and slow charging. You have dedicated short-range communications for the vehicle-to-vehicle, vehicle-to-infrastructure communication. You have people working on developing an understanding of how 5G may work, but understand that the biggest security issues are in Wi-Fi and cellular. And so moving to either of those as a communication profile is understanding that we have to ensure that those networks are completely separable from the powertrain and the engine management networks so that anything that comes in can't affect those parts of the vehicle. So when we look at where they're going and where the opportunity is, we really have to ask ourselves is that as we see this environment changing, as we have less need to be actively involved in the driving, and as we have more need to be actively involved in the ability to take over once you exit the closed freeway, or once an issue with weather or traffic or road condition occurs that the intelligence in the vehicle can't handle. So those are the kinds of things that when we look at is that you don't want to look at how the simplicity of getting the point A to point B is you want to look at the complexity of all the different things that could or may happen on that drive, and that's where the opportunity is.
Thanks, Scott. The next Scott is, I'm working on intelligent hybrid electric technology development, which will interact and react as per the user's driving. Connecting vehicles with such technology to connect with each other to avoid collision, self-driving, and even extending by driving efficiently. Can this type of automation be something that will be that could be OEMs could be interested in? That's one of the questions for you.
It is, but no one will sell it to the tier one, to the OEMs except for the tier one. That's one of the fundamental misconceptions about this environment. People think, oh, I'm going to go sell this to GM or to Ford. They don't have the technical depth to understand it. They put together packages, and those bidding packages go out to the tier ones. And the tier ones decompose it and say, okay, I need to get this from a tier two and maybe this from a tier three. And understand that all of the tier ones can act as tier twos. Delphi can make parts for Bosch or Continental, and Continental can make stuff for Denso, for all that matters. So what you really want to do is when you have something of interest, you want to approach a tier two that would bundle that with his subsystem, or a tier one that can bundle it with their capability, because all the tier ones sell to all the OEMs. And they know which one would be interested in the particular technology that you're bringing to them, and they know how they can bundle it with their other parts and services to make it a more compelling buy. So it doesn't really matter whether you think an automaker could really use this or not. What matters is to have the tier one tell you, GM wouldn't be interested in that, but Ford might. And then they know how to go approach those because they already have the points of contact.
The next question is ADAS, LiDAR, radar product space is already crowded and dominated by big name companies. Where do you see new opportunities for entrepreneurs in this ecosystem?
Well, there's always going to be opportunity. I mean, you know, the question is the issue right now for LiDAR is to making it cheap. When you look at the average automated vehicle, the GM Bolt that they have, the Chevy Bolt, or any of the others out there, to make a car automated using LiDAR and all the other appropriate equipment costs about $80,000 per vehicle. So the issue isn't creating a better LiDAR. It's figuring out how to manufacture it cheaper. And right now, you know, companies like Tesla aren't even in the run for automation because they only have radar. And unfortunately, Tesla tends to use its car owners as their test dummies, and that's not an appropriate way to move forward. You have to have both LiDAR and radar to get through all the weather conditions that may occur. So when we're looking at that market, it's like, yeah, there's a lot of little companies that are formed out there and a few big companies that are being acquired by the tiers or by the OEMs because they know they need that technology. The question is that, is there another way to do it? Is there a more efficient way to produce that product? Okay. Is there a redundancy? Is there a system that we can create that would be a redundant system for LiDAR or radar that would help? And not just necessarily video. You know, the question is how do I build a car that has redundant systems? If I have radar and I have LiDAR, there are failure scenarios for both of those. If I have radar and LiDAR and video, that's much fewer scenarios, but still ask yourself the question, how do I ensure the integrity of the systems if failure occurs? And that's where the opportunity lies.
Thanks, Scott. Scott, the other question is, there have been a lot of acquisitions which are mainly acqui-hires. You saw Delphi's acquisition recently of Nutonomy for $400 million. Ford had the acquisition for Argo. But is it mainly talent that these companies are being acquired for, or are there products? Because when GM acquired Cruise, they did not even have a finished product yet. So at what stage should an entrepreneur be pitching, whether it's an OEM or tier 1 or a tier 2? Is it at an MVP stage, or should he have a finished product? That's what, because if an entrepreneur is not looking to be acqui-hired, the question is, at what stage should they be pitching in this ecosystem?
You have to have a minimally viable product. If you don't have an MVP, then it's just vaporware. You know, and the automakers hear, and not the automakers, but the tier 1s hear pitches from people all the time. And they've become very critical on whether or not it's actually real or not. You also have to realize is that most people have one idea. They have one thing. And what you really want to do is you want to find the right party to combine that thing with so that you have more value. So that if you have some capability, it doesn't matter whether, let's say it's an ADAS, you have some lane keeping capability, you don't want to build a computer that only runs one program. You know, that's called a personal navigation device. You want to build something that can be integrated into the packages that exist in the car seamlessly. The faster you can do that, the more likely you're to become a supplier. The more work that the tiers have to do in order to incorporate what you have, the less likely they'll be interested, because they'll have to spend a lot of dollars for what essentially is very little margin on a per unit sales.
That's very good. Thanks, Scott, for some very good answers to a lot of wide variety of questions. Do you have any perspective in summarizing your thoughts to our audience, Scott?
Yeah, it's the second bullet, the second and third bullet that I have on this last page. Can you share my screen?
Yeah.
Is my screen? Okay. One of the points I wanted to make is that if an enterprise, and I don't care if that's a one-person company or a large corporation, if they're not embedded some way in this connected and autonomous vehicle domain, providing value to the system somehow, it's going to be subservient to its need. I want you to think about that. If you're an insurance company and you're not doing usage-based insurance, you're just going to end up being a data file for somebody else to go look at. If you're developing some intelligent system for managing pedestrian traffic, if you're not communicating that to the car, okay, then it's just going to be using you and you won't benefit from it. The other thing that's important is the next bullet. All of the assets, the people, the technology, the systems that are developed to support this ecosystem are readily transferable to opportunities in other domains. In rail, in freight. You think about the management of freight and traffic as it comes off of planes or ships or trains. It eventually has to be transferred to something that uses the road. A semi, a tractor trailer, a livery truck, a lorry, whatever. That intersection of those two things is ripe for having efficiency. Right now at the Port of Los Angeles, trucks coming in may have to wait a day or two to drop off their load and another day or two to get replenished on the load. And they're working on a 10-year program to communicate from the ships at sea what's in the containers, who's going to get it, so that they can put it directly off the ship into a staging area and the truck gets loaded and save 3 days' time. So you have to look at where the inefficiencies are, that whatever you're developing for this environment probably has an opportunity in other environments, in smart city, in smart grid, in smart home, in other spaces. You want to make sure that you have multiple ways that your product or service provides value across multiple domains.
Thanks, Scott. That is very, very helpful. You know, this is a incredible space where you see innovation happening every day. You see investments happening every day. You see more rapid change in the past few years than probably has happened in the past 20, 30 years. For entrepreneurs and startups, I think Scott's perspective is very, very true. They need to look at it from multi dimensions. they also need to make sure that they are surrounded or connected in an ecosystem to people like Scott, to investors, to OEMs, to tier ones, because you need to always know what your client is thinking. Also, as Scott said, you need to find a way to get to the client, and sometimes it's not directly to the OEM, to the tier ones, to the tier twos. And I think one of the things AutoNebula has done is to build that ecosystem, to build that access to startups. And we are lucky within AutoNebula to have Scott as a mentor to our startups. And, so with that, we like to conclude this webinar series. It has been a great from all the questions, and there's still a bunch of questions, Scott, that have come in that I've not even presented to you. We will be sharing a video and the audio of the presentation as well as Scott's presentation to all the people who had registered for this, and we'll be announcing our next webinar series also to our guests. Thank you, Scott. Thanks, Parag.
Thank you very much for everyone participating.